Looks like I'm in the right spot. Organic chemistry. Hi, Dr. Romano. I'm back.
Hi, how are you?
Doing okay. Can I come and take a look at what you're doing?
Come around and I'll show you what we got. It looks going to look a little scary, but...
Whoa, Dr. Romano, that is a big problem.
Now, what I want to do is to go over a problem with you. I'm not going to hold you responsible for knowing how to draw the mechanism, but I want you to understand the mechanism. That when I make a move with an arrow, you understand where I'm going with the atom or the electron pair, etc. The DAT is going to definitely test you on your ability to understand if you attack something where the arrow moves. So let's get right down to it, and I'm going to show you all the mechanics of what I've done on this reaction. Now,
okay, Dr. Romano, let me get back around.
in this reaction, I'm taking a single molecule and I'm literally doubling it. As you can see, a phenyl and a carbon on both sides. So what I've done is done a reaction called a condensation reaction. That I'm going to condense actually 2 moles of this. I'm going to use catalytic potassium cyanide, ethanol, and water. Both of these, I'm hoping you remembered, are good polar product solvents. In the very first step, I'm going to take benzaldehyde and I'm going to do a nucleophilic attack. Now, this is a very special nucleophile because it's what we call ambident. Ambident means that I can attack you from either side. The nitrogen atom is more negative, and it's going to hold the electrons tighter. So therefore, the electrons are more looser on the carbon side. So I'm going to use carbon as my nucleophile to attack the anti-bonding orbital of the C double bond O. And as you can see, I make my attack. When I attack, this arrow goes this way, and this bond moves out. And that gives me this structure right here. And all I would do is, you never want to have an O minus. An O minus is going to pick up a proton. Either one of these can serve as our proton donors. I'll use ethanol. And we form our tetrahedral intermediate. Now, here's where it gets interesting. In my next step, this proton now is very, very acidic. When I remove this proton off, it gives me this very, very stabilized carbanion. Notice it's going to be stabilized because you have an electron withdrawing group. Now, this carbon that was once upon a time electrophilic. So let me go back to the top and show you. This carbon was electrophilic. As you can saw in step 1, it was attacked by a nucleophile. The electrophilic carbon now becomes nucleophilic. So what I've done is what we call Umpulang. Umpulang is a German word. It means we actually reverse the polarity. We've gone from an electrophilic carbon to now a nucleophilic carbon. That nucleophilic carbon now launches an attack on a second molecule of the benzaldehyde to get the structure here. Once again, pick up a proton from either of the proton sources. Once we're here, we just looked to see what we need to do. So obviously this H has got to leave because we need to have a carbonyl group there. So I'm going to take this structure and I'm going to deprotonate it. Once I deprotonate it, now I set myself up for the kill. Normally a cyanide group is a very poor leaving group, but not in a basic medium. Basic medium, it could leave, and you have a very negative O, and notice the driving force will be the formation of the carbonyl group. We expel the leaving group, and as you can see, finishes out the product. If anyone's curious, what I've just done is known as the benzoin condensation. Even though I think that that is a hard problem, you're not going to have to draw out a mechanism on the DAT. But if you can understand these mechanics, this will be your way to be on the road to that 30. Last summer, we had 72 kids in our group who got perfect scores, and hopefully I could make that 1,072 by having you also get a 30 in this section. I will say goodbye to you. I hope you enjoyed this clip. This is a tough, challenging problem. The important thing is know the arrow movements. All right.
Thank you, Dr. Romano. Would you like me to bring you back a snack or anything?
No
Are
snack.
you hungry?
Thank you very much. Good day to you.
Good day to you, sir. Good day to you.